Okay, guys, so take out your 725 notes. And today we're going to learn another way of writing proofs. So far we've been working with flow proofs. So this is the one that we worked on yesterday. And today we're going to be working on two column proofs. So 725. Let's go ahead and start at 7-90. So the following pairs of triangles are not necessarily congruent, even though they appear to be. Use the information provided in the diagram to show why. Justify your statements. Okay, so again, they're not necessarily congruent. We are going to figure out why they're not necessarily congruent. So the first thing that I'm noticing is that we have a side. I have the 23 and the 23, okay? And again, we can pick those sides out because they have the same measure. I see that we also have another side, a 26-inch side and another 26-inch side. And then they're giving us a 48-degree angle. Now the problem is, if I was to actually cut this triangle out and rotate it, and you guys can see me doing that, you can see very clearly that the pink and the orange side line up, but the blue side doesn't. I can't, no matter how I rotate it, there's no way for me to get this triangle to fit on top of that triangle. And that's because the angle on the left triangle is touching both the pink and the blue side, but the angle over here is only touching that pink side. It's only touching that 23-degree side. So we would say, as of right now, these are not congruent. For B, let's take a look again. I see I have a 9 here and I have a 9 here. So we're going to call that a side because they have the same measure. I know I have vertical angles. Vertical angles are always congruent to each other. But that's all the information that I have. I cannot assume that those sides are congruent to each other. So again, we cannot conclude that these triangles are congruent. We only have a side and an angle, and there's no such thing. So I cannot conclude that any of these triangles are congruent. The next thing we're going to do is we're going to practice writing a flow chart again. So write a flow chart to prove that if point P on line L, not on AB, is a point on the perpendicular bisector of AB, then PA is congruent to PB. That is that point P is the same distance away from both A and B. We call that equidistant, same distant. Okay, so we're going to start by writing our proof. So the first thing we have to do is we have to write our given. And I kind of underlined what was given to us. So they're telling me that PM, so I have line PM is the perpendicular bisector of line AB. So they gave that information to me. I'm trying to prove this information. So I don't know this yet. I'm trying to prove that, okay? So PM is the perpendicular bisector of AB. Again, that's what they gave to me. So what are some things that I can pull out from something being on a perpendicular bisector? Well, I know that angle PMB has to be congruent to angle PMA. And again, that's kind of the definition of perpendicular. And in parentheses, I'm going to put both 90 degrees. So both of these angles are 90 degrees. And again, what I'm trying to get at to prove is that this segment has to be equal to this segment right here. So far what we have is an angle, so that's good. That's a good starting point. The next piece of information, so I used the perpendicular, but I haven't used the bisector yet. So if you guys recall, bisecting something means cutting it into two equal pieces. So if AB is cut into two equal pieces or bisected, I know that the part from A to M has to be equal to the part from M to B. And again, that's the definition of bisector. It's cut into two equal pieces. okay, cut into 2 equal pieces. Excuse me. And again, so what I have there is a side. I'm going to start marking this up. So I have a side, I have an angle, and then of course you guys are probably saying to yourself, well, I know that you have another side, you have PM is congruent to PM, and that is the reflexive property, or any segment is congruent to itself. Okay, so because we have these 3 pieces of information, we know we can come together and say that triangle PMA has to be congruent to triangle PMB. And the reason is side angle side. Now, what's so special about making this green triangle equal to this orange triangle is that if you remember, what we're trying to do is get that pink segment equal to that pink segment. Okay, so by making the green triangle equal to the orange triangle, that pink part, PA, has to be equal to the other pink part of PB. And again, you can come take a look over here, PA and PB. Okay, those parts have to be congruent. So if triangles are congruent, then their corresponding parts have to be congruent to each other. So this is an example, again, of a flow proof. So it's just kind of flowing through here. You see how everything gets put together. We are going to rewrite this proof, and we are going to rewrite it as a 2-column proof. So instead of using arrows to indicate the order, this style of proof lists the statements and reasons kind of in a linear order from first to last. This is how I like to do it. It's a little more organized for me. So we are going to rewrite this proof. A lot of times you guys are going to see like if-then statements. It's also going to put it a little more logical in my brain. So we're going to, again, prove that this pink piece is equal to this pink piece. And I'm going to show you guys how you would do that in a 2-column way. So on the left side, we write what's called our statements. And on the right side, these are our reasons, like how I know it's true. The reasons are what's underneath here. So these are our reasons. So we're writing our reasons. Again, it's just that a 2-column proof in my mind is just a little bit more organized. So the first thing says that point M is on the perpendicular bisector, blah, 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 and that's our given information. Again, I did the same thing up here. PM is the perpendicular bisector, okay? That's given to us. Then it says angle PMA is equal to angle PMB because they're 90. That's the definition of perpendicular right here. We have that right up here. We did that. PMB is congruent to PMA. Why? Definition of perpendicular. They're both 90. Okay? Our next statement says the definition of bisector. So the definition of bisector must be that AM has to be congruent to MB. Again, because it was bisected. And then PM is congruent to PM because of the reflexive property. Once we have that side and the angle and the side, and if you come up and look at the triangle, you can see it more clearly that it's side angle side. We know that triangle PMA, the whole triangle, has to be equal to triangle PMB. And again, that's because of side angle side. Once we know that PA has to be equal to PB. What's the reason? Well, the reason is if triangles are congruent, then their corresponding parts have to also be congruent. Okay? If cars are congruent, then all of their parts have to be congruent. If triangles are congruent, then all of their pieces or parts have to be congruent to each other. And again, this is the exact same proof that we wrote above, except we wrote it as a 2-column proof. So we'll be practicing 2-column proofs more. This is just a quick introduction. We also proved something really cool, and this is called the Equidistance Theorem. And if you guys were to put any point on a perpendicular bisector. So hypothetically, if I put a point right here, it would also be equidistant away from the endpoints of that segment. Well, what if I put it down here? Wait, I'll use a different color. What if I put it down here? Sure thing, still equidistant away. Well, what if I put it off the line? Well, if you extend the line, it's still on there. And guess what? Still equidistant away from the endpoints of that segment. Isn't that crazy if I put one right here? Equidistant away. You could put a point anywhere on this line, and it's going to be equidistant away. And we could prove it if you want. But again, that's the two-column proof that we will be practicing. Okay, it's time for your 725 review preview.